Greetings, my students. Today we are going to do trig ratios, and this is again in review for your SBAC testing. And today we are going to generate trig ratios given a trig ratio. So that is our objective, to find the trigonometric ratios given a trig ratio. For prior knowledge, we're asked here to find the sine of angle B. So remember, if we want to find sine, the first thing we need to do is remember our kind of acronym here. So SOHCAHTOA. I was jumping ahead to tangent. SOHCAHTOA. Right? So sine is opposite over hypotenuse. And if I want to figure out the sine of an angle, I need to first find the angle. So here's B, the opposite side. So sine of B is equal to the opposite side, which is 5, over the hypotenuse. And the hypotenuse is always directly located across from the right angle, which is 13. So here is our prior knowledge. Okay. Again, remember that we have our kind of trig ratios here for the given angle and our given trig ratio. So sine of A is opposite angle A and over the hypotenuse. Cosine of A, side adjacent to A over the hypotenuse, and tangent of A is the side opposite angle A over the side adjacent to angle A. So what we're going to do today is we're going to be given a sine, cosine, and tangent of an acute angle of a right triangle, and we're going to find the other trig ratios based on these steps. Step 1, place the values of the numerator and denominator of the given trigonometric ratio in the triangle. Step 2, use the Pythagorean theorem to find the third side of the triangle. If you have forgotten good old Pythagoras' theorem, a squared plus b squared is equal to c squared. And step 3, use the definitions of sine, cosine, tangent to find the remaining trigonometric ratios for both acute angles. Lastly, we'll simplify the ratios as much as possible. Okay, so let's go ahead and look at this example here. So I have, if the sine of angle A is equal to 12 over 13, find the following in simplest form. The first thing we also want to do is we want to generate an image. So I'm going to go ahead. I don't like that way. That's picture. Let's do. Sure, we can do it this way. Okay, so here I have my triangle, and we're going to label it A, B, and C. So we have this image. Notice we're asked to find angles A and B, the trig ratios of these angles. So C has to be our right angle. These two are going to be our acute angles. So they say sine of A is 12 over 13. Well, remember that sine is opposite over hypotenuse. So opposite over hypotenuse. So if I want to fill this triangle in, the opposite side is 12. So that means this side is 12 and the hypotenuse is 13. Okay? So that's step 1. Step 2 is to use Pythagoras' theorem in order to go ahead and figure out the third side. So I don't know this leg, so I'm going to say x squared plus 12 squared is equal to 13 squared. X squared plus 144 is equal to 169. Calculating this, I'm going to subtract 144, and we get x squared is equal to 25. Take the square root of both sides, and we get x is equal to 5. So therefore, this side is 5. Okay? And once we have this information, we're just going to go ahead and fill in the rest. So cosine of A, well, cosine is adjacent over hypotenuse. So that is 5 over 13. Tangent is opposite over adjacent. So I have 12 over 5. Sine of B, well, here is angle B, and B is, sine of B is opposite over hypotenuse, so 5/13. And cosine, adjacent over hypotenuse, 12/13. And then tangent is opposite over adjacent, so 5/12. Okay. So this is what we should have gotten. Another example, I have, if the cosine of angle B is 1/9, find the following in simplest form. So we want to find these trig values. Again, I'm going to draw an image. Here's my triangle. So I need to have acute angles of A and B. So I'll say this is angle A, this is B, and here's C. So they say cosine of B, so that means I'm in this angle. Remember, cosine is equal to adjacent over hypotenuse, right? Remember, SOHCAHTOA. So adjacent would be this side, so this is 1, and the hypotenuse is 9. So now I want to figure out side AC, so I use Pythagoras' theorem. X squared plus 1 squared is equal to 9 squared, which gives me x squared plus 1 is equal to 81, giving me x squared is equal to 80. So I take the square root of both sides, and this gives me x is equal to, I know I can break this apart, so I'm going to go ahead and break it into 16 times 5, which is, let me do it like this, 16√5. So that is 4√5. Okay, so x is equal to 4√5. So now that I have all my sides, I can fill in these values. So sine of A, here's A, sine's opposite over hypotenuse, so that is 1/9. Cosine adjacent over hypotenuse, so 4√5 over 9. And tangent is opposite over adjacent, so 1/4√5. And because of the radical, we have to rationalize, multiply top and bottom by the radical, giving us √5/20. Sine of B, B is opposite over hypotenuse, so 4√5/9. And tangent of B is opposite over adjacent, so 4√5/1, which is just 4√5. Okay? So those are our two examples. I'm going to post a practice problem. Please pause the video and try the practice problem on your own. When you have solved it, hit play and check and see if you got the correct answers. Okay, so please pause the video and try this one on your own. Alright, hopefully you have tried this problem. You should have gotten these answers. So we draw our image. Sine of B is 1/3, so opposite over hypotenuse. We place these, and then we have to use Pythagoras' theorem to calculate our missing side. Once you have that, you can fill in these values. Notice here on tangent of B, you had to rationalize. You could not leave the radical 2 in the denominator, and this is kind of what we get out of it. Okay, I have one last notes problem, and this time we are given a tangent. So I'm going to go ahead and draw my triangle. I'll make it a different look this time. So tangent of A is 3/7. Again, our acute angles are A and B, so I'll just label this as A, I'll label this as B, and this will be C, a right angle. A tangent of A. So here's A. Tangent is opposite, TOA, opposite over adjacent. So therefore, 3 goes here, and 7 goes here. So since I have my legs, 3 squared plus 7 squared is going to be equal to my hypotenuse squared. So I have 9 plus 49 is equal to x squared, which is 58 equals x squared. Solving for x, we get radical 58. And can I go ahead and reduce this one? Root 58. Do not believe I can. So we're just going to leave it as radical 58. Okay. And then we're going to plug in these values. So sine of A, opposite over hypotenuse, 3 over radical 58. Can't have a radical in the denominator. Otherwise, Pythagoras might come after us. So we multiply by root 58, top and bottom, and I get 3 root 58 over 58. And that's fine just like that. Cosine of A is adjacent over hypotenuse, so I have 7 over radical 58. Again, rationalize that guy. And we get 7 root 58 over 58. Sine of B, if you're smart, you remember that sine of A and cosine of B, or vice versa, that they're exactly the same. They're equivalent for complementary acute angles. So sine of B, that is the same as cosine of A. So that is 7 root 58 over 58. And just to double check, make sure, here's B. The side opposite is 7 over hypotenuse is radical 58. So that's exactly the same. Cosine of B is going to be our sine value, so 3 root 58 over 58. And then tangent of B, opposite over adjacent, is 7 over 3. Okay? I have one last practice problem for you that I'm going to have you do, and then you will receive the assignment in which you can work on in class. Whoop, it all went black. Okay. Alright, so please pause the video, try this one on your own, and then unpause when you have completed. Okay, hopefully you have paused the video and tried this guy. Given tangent of A is equal to 5 over 2, these are the values that you should have gotten. On this one, you have a lot of rationalizing to do due to the radical 29 being the hypotenuse. That happens if you have a radical over here. The good thing is that we don't have to reduce too much because of 29 being prime, right? These guys don't reduce. Okay, so hopefully you got those. For our closure, we want to match each side of the right triangle to the correct description. So here they say BC. BC, is that the side opposite of A, the hypotenuse, or the side opposite of angle B? Well, it's definitely not the hypotenuse, right? That's BA, or AB. That's the hypotenuse. The side opposite A, well, here's A, that is BC. So there we go. And then the side opposite angle B, well, that's AC. Okay? That is it for the lesson. Don't forget, like my video, subscribe, and Schwarberg is